So we're going to go through one specific IB style question where we're going to follow up with a little bit more vocabulary. So what you're going to do here, I believe this is on your unit packet. So what you're going to do, hopefully you watched the video on how to do these on your TI Inspire, but I'm going to go ahead and walk through it with you one more time. So you're going to take and enter your data here. I've labeled it temp and viz, just so I know exactly what they are. Then I'm going to go to menu, stats, stat calculations, and I'm going to do a linear regression. I'm just going to do mx plus b, but you could do either. I don't care. Mx plus b. Our x list, our input, is temperature. We can tell because they tell us. Thank you. Then we're going to go to y list, visitors. And actually, from there, nothing else needs to be done. So we're just going to go OK. And it's going to give us all this information right here. It tells us what m is. Tells us what b is. R squared can be ignored. Here's R. They've got some residual information. We don't need any of that. So it says find Pearson product, moment, correlation, coefficient R. Well, when you run the linear regression, there it is. There is our R value. So I'm going to go ahead and annotate. Yeah, that's fine. Hopefully this will work. Our R value is point. 0.998, was that what it was? Okay. Then annotate. 99966. That's a really high correlation coefficient. That's like almost a perfect line. If you did this to 3 sig figs, this would actually make it 1.0 if you did it to 3 sig figs, because you'd go 1, 2, 3, and the 6 would tell you to round up, which would create like a roll, right? Which is then going to make that 1.0. But you can just put 0.99966, okay? The equation of the regression line y on x. So we're going to say y equals m, which is 40.3 x plus b, which is negative 402.6 becomes 403 at sig figs. You could also just put minus 403. That's fine also. It says, it's kind of smooshed in here behind it. It says, use the equation of the regression line y on x to estimate the number of visitors when it's 26 degrees. So what we're going to do in that scenario is we're going to say y equals 40.3 times 26. We're going to let that be our input, plus negative 403. Okay. All right, we can go to our home and calculate. And we're going to go 40.3 times 26 minus 403 equals 644.8. So you could round that off to 645, okay, so which is right in this window between these two, which kind of seems like a reasonable estimate. Then it says, I added this question here to get us ready for the next vocabulary question or vocabulary word, which it says use your regression line to estimate the number of visitors if the temperature is 45. So it's a huge jump in Celsius, 45. Does this number make sense or not? So we're going to say 45 degrees. So we'll do the same thing we did before, but instead of putting in 26 right here, we're going to put in 45. So we'll go 40.3 times 45 minus 403, and then we'll hit enter. And we have this pretty big number here, but I'm not sure. So this would be the estimate at least. I don't know how much you guys know about Celsius, but let's convert really quick. 45 Celsius to Fahrenheit. Let's see what it says. 113 degrees Fahrenheit. So yes, it's possible that this number could be right, but because 45 degrees is outside of our window of data we've collected, we can't really be sure. We can't be sure that at 113, people aren't just going to want to stay home where it's air conditioned, right? Like this might not make sense to project out into these larger or really cool temperatures, right? Like maybe if you went down far enough, the number of visitors is going to go negative, right? And that doesn't make any sense either. So what we say here, you guys, is there is a window in which we can make predictions from our regression line. I'm going to show you here on, I'm going to clear. This area right here, if we collect data from in this window right here, from here to here, this is the area in which we can really make good predictions. So when they ask us to look here at 26, 26 is within the data set. We can be pretty sure about the projection made at 26, but 45 is way outside our window. It may not trend the same way after this window. Maybe things flatten out and are no longer linear, or maybe they go really high. We don't know. All we know is information about this window of data. So what we can say, and be really conscientious here, okay? They will ask you, is this reliable or not? Does this answer make sense? And anytime you are asked to make predictions on data outside of the data collection window, you can say, no, it is not a reliable estimate. And that's because it's called an extrapolation. So projections made outside of the data collection window are called extrapolations. So if you made any predictions out here or predictions back here, those would be all called extrapolations and are not necessarily reliable. However, data or predictions made with data in here inside the data window, those are called interpolations. Interpolation. And those are available to be good for prediction. So this is a good prediction window. They do tend to assess on this vocabulary. So do make sure you know the terms extrapolations versus interpolations. The last thing I want to cover here is this, we talked about it briefly earlier, which is the idea that even though there's an association, even though there's a correlation, okay, we are not using those two things. We cannot say causation. So one of the things that kids get marked down on their internal assessment from IB is very often they'll say, oh, there's a causation between these two things. Well, not necessarily. We can't prove that. And so the last video you guys will watch today will be on how the medical industry and the government had, like, how many hoops they had to jump through to actually prove a causal relationship between smoking and cancer. So you'll watch that, and I want you to keep track as you watch that relationship on all of the different ways other things could be causing a relationship like this, what other kinds of things could cause a relationship, and what things do you have to show really in order to show causation. So what are the things you would look for that would actually allow you to make the claim of causation?